Of course, this would not be an engineering course if I didn't throw a formula your way. The formula associated with permeability is the so-called Darcys Law, where Q equals to the product of K, I, and A. Q refers to the flow rate, and it's typically expressed in cubic centimeters per second. K is the hydraulic conductivity or coefficient of permeability, and it's typically expressed in centimeters per second. I is the hydraulic gradient. More on this in a moment. And A, capital A, is the cross-sectional area in centimeters squared. Let's now review each of these variables with the aid of a figure. Let's consider for a moment this simple test setup. Water is fed at the source here, which is the highest point in this setup. It then travels through the tube with a cross-sectional area A and exits at this lower point right here. As the water is traveling through the tube, it passes through a sample of soil with a length of L. The difference in elevation between the source, the high point, and the exit, the lower point, is delta H, the hydraulic head. Depending on how quickly water passes through this length of soil will determine the permeability of this sample through the coefficient of permeability K. The hydraulic gradient I is the ratio of the hydraulic head delta H and the length of soil L. If Darcy's law is rearranged, it can be rewritten to calculate the coefficient of permeability K as follows. The test setup that will actually be used during your lab will actually be more similar to this. I encourage you to review Lab 4 as linked in your Blackboard. You can also access it by clicking on the word soil. So, as previously mentioned, please be sure to review Lab 4 under its folder on Blackboard for more details on the testing procedure. An interesting note is that, for the purposes of determining the permeability of a soil sample, it turns out that it is considered more reliable to do so in the field whenever possible. Let me repeat that. Typically, it's more reliable to determine the permeability of soil in the field rather than in the lab. As food for thought, I would ask you, why do you think that is?